Hello everybody, my name is Joshua and I'm here to talk to you about the Flamingo project in preparation for the Flamingo Hackathon event that you're all participating in. Flamingo is essentially an API we've developed as part of a consortium of companies which encapsulates a high accuracy positioning service for both smartphones and IoT. And specifically today, we're going to be focusing on smartphones. First, I'm going to show you a brief video that introduces you to Flamingo and what it is. So please sit back and essentially, in this video, we're trying to summarize what Flamingo is in terms of an API developed to access by and it's summarized with 5 steps. So yes, that gives you a main idea of what Flamingo is. And now, throughout this presentation, I'm going to go into further detail about what it is, what it was driven by, and then talk about what is its enabling factors. So Flamingo is a high accuracy positioning service to be used by mass market devices. And it comprises of many different elements. You've got a core positioning engine, which is calculating accurate positions based on using raw GNSS data. It is a high capacity architecture. So Flamingo is designed to be scalable to thousands, hundreds of thousands, even potentially millions of users at once. And interfaces for very simple integration. The consortium consisted of 9 different organizations led by NSL, which is where I'm from, and it tries to essentially bring together some of the best of European GNSS capabilities. As alluded to before, it consists of various PPP and RTK infrastructure, products, service provision, and user solutions. And the target is accuracies of 50 centimeters or better. And we believe that the service delivers on this. We will also demonstrate its use and facilitate uptake through free citywide long duration demonstration events, dedicated hackathon and participation in other hackathons, and also the support of other initiatives, e.g. The European Union GNSS Task Group, which essentially illustrates and teaches people on how to utilize raw GNSS through Android smartphones. So to give some summary of the GNSS mass market context, which is essentially what Flamingo is trying to target. So we're seeking to address higher accuracy positioning in devices that millions and millions of users essentially have integrated into their everyday lives. As you can see in these images, we've got iPads, you've got smartphones, and you also have these wristbands, smartwatches, and that is bringing together these very large numbers in terms of using GNSS services. Easily accessible being a key area to address. But another key factor is these systems are commonly comprised of very low cost and common receivers and antennas. And this can present some particular challenges to deliver high accuracy positioning. What is also new in smartphone GNSS? Before 2017, we actually couldn't get access to raw GNSS data. What we have now have access to since 2017 is an API known as raw GNSS measurements, which is being delivered from Google, and it allows us to essentially collect the different measurement data you can get from the satellite navigation systems, and we can utilize that in the best way to improve GNSS accuracies on board the smartphone. So you can get pseudo ranges and carrier phase and signal to noise ratios of the actual GNSS themselves. And also what has been released since essentially 2018 is this new dual frequency chipset developed by Broadcom, and that allows for the first time single frequency from both L1 and L5 signals to which allows us to improve and augment positioning much more accurately. And essentially what we're doing is then harnessing also different constellations of satellites that have come across since the last 5 years, such as the European GNSS system, Galileo, which is what this project supports, Beidou, which is the Chinese constellation, and GLONASS, which is the Russian system, as well as these dual frequency L5, E5 signals. And coming together, you kind of hit this sweet spot of increased availability and improved accuracy that allows you to deliver on essentially a sub-meter positioning target, which is what we achieved with Flamingo today. It's very important though, and I recommend going onto this website, that your smartphone is supported by Flamingo. We have an app that you can download called GNSS Check that allows you to determine if Flamingo is enabled in your smartphone. It's very important that this carrier phase, pseudo range, L5, E5A signals are enabled in your smartphone to gain the best accuracies possible of the service. Now, we have many issues with mass market uptake. New capabilities are introduced in GNSS, more satellites and signals, greater potential, and this raw measurements API and the dual frequency chipset. However, this adoption within smartphones today is very, very limited. As I showed on a previous slide, currently we've only tested Flamingo dual frequency, which is the highest accuracy you can get on a Xiaomi Mi 8 smartphone. It's very important that you have access to the smartphone. I understand that the Huawei Mate 20 has been released, which has access to dual frequency as well, but this is untested for. So at the moment, it's just Xiaomi Mi 8. And industries and institutions are facilitating how to fully benefit from this device, from these new capabilities. But it's very important that we have early adopters, a device churn, and looking at the sorts of applications that can be enabled from high frequency, high accuracy positioning. With newer applications, we can demonstrate the case for why increased accuracy is so important, so then it delivers the demand needed to realize more devices into the market. And these couple of videos here kind of emphasizes why high accuracy is important. So here we've got an augmented reality based environment. We've inserted a shed. On the left, you've got 3 to 5 meters of accuracy, and then Flamingo is enabling this sub-meter accuracy. And as you can see, the shed is basically inserted much, much better into the environment. And this is just for an augmented reality application. So there's many new applications as well. which I can address for, which I'll address in this presentation. Can we meet the accuracy? As we said before, the smartphone is an entertainment communications device. People are much more interested in using Facebook, Instagram, taking photos than high accuracy positioning, and so the manufacturers do not prioritize GNSS in their device. It's a low priority, there's lots of RF interference, the antenna is buried and shared with other systems. So typically sometimes the Wi-Fi antenna or the Bluetooth antenna is shared by the GNSS receiver. And also the phone does prioritize power consumption. It wants to have a low power consumption. GNSS can sometimes use a high power. Also limited by user control. City environments present a significant challenge to getting access to satellite signals, and that also does not present a nice environment for high accuracy positioning. All in all, smartphones are not nice GNSS devices. However, with Flamingo, this is a chart that kind of illustrates what we can do with Flamingo. We can get sub-meter accuracies with a number of smartphones. Up on the left, you've got smartphones that haven't been enabled by Flamingo, and that shows you some of the accuracies presented in a static scenario. And then down here, you can actually see how accurate we can get things. And looking at the applications, there's many different applications that require a sub-meter, 50 centimeter accuracy. As you can see in this image here, we've got augmented reality. If you want to identify where your coffee shop is, and you want to hold up your phone, you can't have a 5 meter accuracy and it jumping all over the place. You should have it pinpointed to the door of where you want to go into to really have this sort of application as useful. Visually impaired navigation, having somebody who has a limited sight capability to identify where a traffic light is, where a pole is, that requires a much more accurate positioning service. And as I said before, we've got a number of different events happening, demonstrating Flamingo, and through Hackathon as well, we now have users throughout Europe now seeing what the realization of Flamingo delivers on. And we've done a number of demonstrator level applications as well. We've got surveying apps, pedestrian navigation, fitness, again some really accurate fitness stats based on a more accurate location, vehicle navigation, so you can identify what lane you might be driving in, tracking, and augmented reality. And this is to illustrate the encapsulation and show some of the infrastructure that's needed for it. So a key enabling factor for Flamingo is having a reference station, a GNSS reference station within proximity to the Flamingo device. These reference stations sending RTCM data over to Flamingo, and then that's providing corrections to you. It's very important that you are within vicinity of a Flamingo qualified reference station at the moment. This is the enabling factor of delivering high accuracy positioning. If you're not within sight of one of these reference stations, Flamingo will not operate within your area. Using this and sending across these corrections and also the signals from the satellites, we've got a core positioning engine being used inside smartphones that will allow you to get a much more accurate location fix, utilizing the best of the data available. And then in encapsulation stage 2, we've got an SDK platform that is very simple for you to install on your device. As illustrated in that video, it's exactly like Android location, so it provides the most simplistic modification that you need to get at more accurate locations compared to Google Android. There's instructions on here, different methods, register Flamingo service, so you can get access to the raw measurements and then just calling a location. These are the smartphones we've tested with at the moment. Currently, we recommend Xiaomi Mi 8 because that provides dual frequency data. Huawei P10, Samsung S8, yes, you can use Flamingo with them, but they're not going to provide you the accuracies that you may need for your applications. And again, you can use GNSS check application for compatibility testing. So please go on the Play Store if you want to see if your smartphone is compatible with Flamingo. And this slide here just essentially emphasizes the simplicity of Flamingo into your application. So essentially you've got from Android location to Flamingo location. It's just a simple change of a method name and variable names, and you can get a much more accurate location from it. So yes, thank you very much. Please go onto the website to read more, and thank you for listening.